Hello, Professor. We are a team consisting of Goyen, Carrie, Daniel, and myself, Chris. And we have our analytic projects on credit card default data analysis. So we want to do a classification problem of whether there will be a default or not. And the data set is a Taiwanese credit card data set. And we wanted to focus on a subset of customers because the data set was so large. So we decided to do a subset of customers who have graduate degrees and are age 30 or younger. The best model we found that we did was a neural network model, and we had an R-square of 0.246, and we created an expected profit of $20,468,000. And for our problem statement and hypothesis, we wanted to discuss how defaults are costly in the banking industry, plus credit card holders who are early in their career don't have too much disposable income and not too much credit history, which is part of our particular data set. So how can a bank predict the propensity of default for customers who are age 30 and younger and who hold a graduate's degree? Our null hypothesis is for applicants age 30 and younger with graduate degrees, you cannot identify the variables that will determine the likelihood of the default. And the alternative hypothesis is that for applicants age 30 and younger with graduate degrees, you can identify variables that will determine the likelihood of default. And Carrie will be discussing the data description next.
Okay, thank you, Chris. So in our research, we employed a binary variable, the default payment, as our response variable. And for the explanatory variables, we have some demographic variables such as sex, education, level, and marriage, and age. Also, we have the amount of giving credit for each data point, and the history of past payment, and the amount of the past bill statement, and amount of previous payment. Also, we applied some enrichment data, such as we have the credit utilization ratio. We divided monthly bill by credit limits. And we have the percentage amount, how much of the bill is being paid off per statement period. Also, we have the total payment bill. Also, we have the total payment amount divided by the bill amount, which gives us the percentage amount of how much bill is paid across all the 6 statement periods. So looking at all the data we have, we got some basic insights from this explanatory data. First of all, we saw the limit balance was screwed to the right, and the 1 month's payment, the first month's payment amount divided by the bill was screwed to the left. And overall, from the payment status, we saw it looks like the majority of customers paid their bill on time. So having understand these basic insights from the data, we conducted some analysis. So we saw the applications, the applicants aged from 30 years old and younger with graduate degree give us about 4,300 data points. And we split these data points into training and testing data set, using half of the data points for training and the other half for the testing. And then we ran a stepwise regression with all our independent variables, and then to determine the significant variables. After finding out the 6 significant variables, we ran the logistic regression model and neural network model to get our best and the second best model. And then we want to figure out the profit and loss. So we use the average limit balance and average statement balance. We assume a margin of 2% and an interest rate of 6%. And discounting it over 5 years, then we got the profit And then we look at all our models to calculate the profit for all the models. Then we can get which model is best and the second best.
Thank you, Carrie. Moving on to our analysis, as Carrie mentioned, there were 6 significant variables found from our logistic regression, and we went ahead and used those variables in our neural network model, which ended up being our best model. We got an R-squared of 0.251 for the training data set and 0.246 for the testing, which then gave us an expected profit of 20,468,000. We also had very strong ROC and lift curves. The area under the ROC curve was about 0.77. And for the lift curve, the first 5% of the data gave us a lift of 3.5 to 3.7. This means that our model can predict defaults 3.5 to 3.7 times better than randomly. And as percentages got higher, the lift dropped. At 15%, the lift was about 2.5. Moving on to the discussion of the model, all of our findings pretty much made business sense. According to the profiler, the probability of default was slightly higher for customers that either had very low limit balances or very high limit balances. And this makes sense as customers with very low credit limits either have shorter credit histories or less income, which makes them more risky. And having very high limit credit limits can make a customer risky because they can also spend more. We also found that the probability of default was higher the more late payments that customers had. Also, as the bill payment amount increased up to 1,000, we found that that decreased the probability of default, and that we saw the line plateau on the profile after 100,000. And lastly, the lower the ratio of the bill to pay, the more likely the customer was to default. This also makes business sense because if they're not paying the full balance or not paying on time, it can mean that they can't afford the bill or they have too much debt, which overall makes them more risky. And finally, our cutoff here was 50%. And our next best model was our logistic regression model. The overall model itself had a p-value of less than 0.001, which made it statistically significant. And also all our 6 significant variables were also had also a p-value of less than 0.0001, which also made them significant. We got an R-square of 0.217, which was a lower R-squared than our first model, but we got a slightly higher profit at 20,471,000, and we also had the same cutoff at 50%.
Great, thank you. So to look at some concluding business insights from our analysis, we divided it into some obvious and non-obvious findings. The obvious finding that we already mentioned is actually that people who delayed payments were most likely to default, at least within the population of graduate students who are age 30 or less. This seems obvious because if a customer delays their payment, it already indicates a lack of ability or lack of willingness to pay, and therefore suggests that they're more likely to default. A less obvious finding is the plateau that happened, where the probability of default kind of plateaued after increased the bill payment up to 100,000. This is a non-obvious finding because we believe that there isn't a logical necessity or logical reason why people should plateau in their probability of default as the bill payment increases. I think the intuition might be that as the bill payment increases, the probability of default will increase as well, decrease as well indefinitely. But this was not the case. And to take it a step further, even if there is a default, there doesn't seem to be a logically necessitating reason why it should be 100,000. So it was an interesting and less obvious finding from our analysis. Finally, from a profit analysis, we can see the different predicted customer numbers based on different models, and then the top 2, the logistic regression and the neural network. clocking in at 20.47 and 20.46 million, respectively, profit from this population. So some possible future improvements to this entire process would be, I think from the very beginning, we realized that the data cleanup was a very difficult process. We believe that a way to fix this would be to collect data in a more structured and clean way. This would make it much easier to do wider analysis, to segment by different populations, and to add or enrich more variables to the analysis. Again, going back and cleaning the data is possible, but it's just very difficult. Collecting good, clean data is probably just the best practice. And finally, just to conclude, our best model, we believe, is a great predictor of default. We have a very appealing profit number at R squared of 0.246. And we believe that as we go forward, the business can take the feedback loops from customers and their performance over time in order to update the data set, retrain the model, and see if we can get an even better result, a better understanding of our customers, and of course, better profitability for our company. So thanks very much, and that's our presentation.